Hi guys, in this video we are going to look at another first class lever, but this one is a little bit tricky. Why? Because we are not allowed to ignore the mass of a stick here. So this is our stick, okay? Let's first have a look at the answer, the mass of the object here, assuming that the stick has no mass. So I have one moment, force times distance on the left side, and I have one moment on the right side. So the principle of moments is the sum of moments. Anti-clockwise is equal to the sum of moments clockwise. So as I have only one moment, and moment is force times R, maybe I should write it down here. So moment is force times distance, and in this case a force is a mass times g times distance, because the force here is the weight of the object, right? So mass 20 grams, no need to convert it to kilograms, because if we keep grams on the left side, then we will get gram on the right side. So 20 times 9.8 times 20 centimeters is the distance, is equal to mass, we don't know, and g 9.8, distance is 40. So if we rearrange the equation, the answer is 10 grams, right? Now we are going to look at the question again. We are going to find the mass of the object here, assuming that the mass of a stick is 10 grams. So I want you to imagine this. Let's say we have absolutely no loads hanging from the stick here. Okay, I have only one stick here. I'm trying to show you. Let me use, this is much better. Okay, so I have a stick here, and the length of this is 60 centimeters, right? And here I have a piece of string, and my stick is hanging from this point, which is the pivot, right? So I want you to tell me if the lever is balanced. The answer is no. Why? Because the lever is going to rotate clockwise here. And how do I know that? So do you remember the concept of center of gravity? The center of gravity, the stick, is right in the middle of that. So I'm going to show the center of gravity here. So this is the center of gravity, the center of gravity of the stick. And from that point, we have the force of gravity downward. Okay, so I have this force here, and I have absolutely nothing on the left side to cancel this one out. So my lever, or the stick, is going to rotate clockwise. I am going to add the objects. So I have this 20 grams here, and then I have something that I have absolutely no idea, that we're going to work it out there. And then I have the weight of the stick right in the middle, which is the mass of a stick, 10 grams, times g. Now I am going to use the principle of moments to work this out. So here is what I'm going to write down. So on the left side, I have mass times g times r, right? I have only one force here. That means that I have only one moment on the left side. On the other hand, on the right side, I have two moments because I have two forces here. I have M, which belongs to a stick, times G times R, which belongs to a stick, plus the green one, M times G times R. Then I am going to substitute the values in the equation. So what do I have? On the left side, I have the blue one. Mass is 20 grams times G is 9.8. 0.8, sorry. Times distance is 20 centimeters. Is equal to, then I have the stick here, mass is 10 grams times G is 9.8 times distance. Look at that. Let me write it down later. I'm going to show you. The distance is 10 centimeters plus the green part, mass, we don't know, times G 9.8 times the distance is 40 centimeters. Okay, let me show you these distances. So this is brushes here. So this is the distance. Oh no, green. So this is the distance, 40 centimeters. Right? And as I said, the center of gravity is right in the middle of the stick. The length of the stick is 60 centimeters. So this distance is 30 centimeters and here we have 30 centimeters. That means that the distance here is 10 centimeters. Right? And the other side we have 20 centimeters. Now what you are supposed to do is you are supposed to rearrange the equation here and get the answer. So if I want to do that, this is the answer. So if we rearrange the equation, then we will get mass is 7.5 grams.